The 164, the new sedan from Alfa Romeo, has been designed to express the importance of Alfa in terms of fine quality vehicles. This vehicle has a completely new line, distinguished by its aerodynamic profile, highly sporty nose, and the precision of its finishing touches, all features that make the 164 a truly high-class vehicle. Its performance is second to none, combining speed and acceleration with extremely reliable road holding and comfort features. Alfa Romeo has succeeded in synthesizing and coordinating high-tech features with an elegant, sporty look to produce a vehicle that qualifies for high ranking on the list of top-class saloons. In keeping with the sporty, high-performance quality of this line, the aggressive-looking nose is given extra width by rectangular headlights and wraparound indicators, which merge into the sides and bonnet. The bonnet, which is shaped to soften the nose's imposing look, runs smoothly into the Alfa badge. The wide windscreen is securely stuck in and slants sharply back to improve the vehicle's aerodynamic performance. The rounded front window posts are neatly joined to both the windscreen and the doors, which curve round into the roof. The door handles are merged into the bodywork, improving both look and aerodynamic performance. The line of the boot lid continues up to the roof over rear window posts and sloping rear window. The front and rear bumpers and the trims on the sides and doors are made of synthetic material. These details not only protect the bodywork, but accentuate its graceful line, and so increase agility as well as being functional and elegant. The symmetry between radiator cowling, bonnet and windscreen, and between rear window, boot lid and boot give the vehicle its distinctive wedge shape, which makes the airflow sufficiently close to the vehicle's profile to reduce the drag coefficient. An additional advantage of the vehicle's aerodynamic superiority is that the reduction of the air swirls helps keep the glass surfaces clean. The use of specially shaped seals on the door profiles and of rubber edging on the headlights and radiator combine to reduce swishing and swirls. As a result of the solutions adopted, the 164 has a drag coefficient that is 15–20% lower than any other sports saloon on the market. This means that it is 4 to 5% faster than other vehicles with the same engine and consumes about 10% less at the same speed. Particular care has been taken with the vehicle's aerodynamic lift, with spoilers placed under the front bumper to avoid excessive height variations at speed and improve road hold. In terms of internal fittings, the overall stylishness and choice of velvet materials make the 164 both highly functional and extremely up-to-date. The bucket seats, fitted with headrests, have been designed to give the most comfortable ride possible. The front seats can be moved backwards and forwards. And the rake can be adjusted. The height of the driver's seat can also be adjusted. These movements are electrically controlled on the 2.5 TD and 6V versions. The driver's seat can be manually adjusted to give added lumbar support. The rear seats have a large central armrest, which can be pushed back into the appropriate slot in the seat back. The upholstery on the front and rear door panels fits in perfectly with the material used on the armrests and on the roomy document pockets. The dashboard is covered with the same material as the armrests and pockets and has been designed with purely functional criteria in mind. The fuse box is located on the left of the dashboard. The wide cluster is arranged so that it has a set of control indicators in the center, the rev count and speedometer at the top, and instruments relating to fuel level, coolant temperature, odometer, engine oil, pressure and battery charge at the bottom. The center of the cluster also includes an outline of the vehicle with all doors open, which lights up when one or more of the doors are not properly closed. The odometer reset push button, the light brightness rheostat, and the indicator lamp control push button are all located under the cluster. A spacious lockable glove box with slow opening device is located on the right of the dashboard. The asymmetric air conditioning outlet is located in the center of the dashboard. The conditioner control panel is below this outlet. The digital clock plus related adjusted push buttons is located on this panel. The radio compartment and the front ashtray are built into the central console under the dashboard. Both are equipped with covers that have the slow opening device. The 164 has central locking devices for the doors and boot, consisting of electrical actuators plus an internal lock push button. This means that all four doors are locked automatically simply by locking one of the front doors. The fuel flap is operated by a push button located on the bottom left of the steering column. The boot lid can only be opened by removing the key from the ignition and by pressing the push button on the dashboard or by using the key from the outside. The external rear view mirrors can be electrically adjusted with select and control push buttons located on the driver's door. The large front windscreen and side windows give excellent visibility. An electronic control unit makes sure the 164's air conditioning heating system functions perfectly. The automatic climate control makes sure that the temperature inside the vehicle is kept constant at a preset value, regardless of the vehicle's speed or the weather conditions outside. The system consists of a set of sensors that send electric signals to an electronic control unit. This electronic control unit then processes the signals received and sends the commands which keep the inside temperature constant at the pre-established value to the actuators. The 164 line has three different types of engines: twin-spark 2.0 engine, turbo diesel 2.5 engine, 3-litre VC. The twin-spark engine with 4 cylinders in line, total engine displacement of 1962 cubic centimeters, is fitted with the injection device and Motronic ML 4.1 electronic ignition. This engine is capable of reaching 148 HP at 5800 RPM with torque of 19 kgm at 4000 RPM. The overall objectives behind the choice of this engine are the following: better performance without increasing consumption, improved constant torque in a wide range of RPM to increase engine flexibility, which gives a more comfortable ride and fewer gear changes, greater thermodynamic efficiency, plus reduction in poisonous exhaust emissions. These targets have been reached through improvements in volumetric efficiency achieved by altering the shape of the piping and the size of the intake valves. Thermodynamic efficiency, that is, the combustion process, has been boosted by the use of new hemispherical combustion chamber with a reduced surface-to-volume ratio, 2 spark plugs for each cylinder, with simultaneous action that gives a twin spark. This improves combustion, reduces not only consumption but also carbon dioxide exhaust emission. The 3-litre V6 engine has 6 cylinders arranged in a V at 60 degrees, an engine displacement of 2,959 cubic centimetres and a compression ratio of 9.5 to 1. The use of a Motronic ML 4.1 electronically operated injection ignition system means the engine can reach 192 HP at 5,600 RPM and a torque of 25 kgn at 4,000 RPM. The 60-degree V6 engine can also boast practically imperceptible vibration and silent running to complete the picture of a powerful and extremely versatile machine that still retains its sporty look. Both the 2-litre and the 3-litre engine are fitted with an ignition and fuel system operated by a Motronic ML 4.1 electronic control unit. The system control unit receives information from the sensors located on the engine and transmits commands to the parts involved in ignition and fuel supply. The control unit keeps the engine's RPM constant as the conditioner's compressor is set in action. The turbo diesel 2.5 engine has been designed to produce a vehicle that is economical to run without sacrificing any of its performance or dash. This diesel engine has an intercooler, operates on indirect injection and is supercharged with an exhaust gas turbocompressor controlled by a wastegate. The presence of the turbocharger and intercooler means that the 2,500 cubic centimetre TD 2.5 engine can give 117 HP at 4,200 RPM and a torque of 26.3 kgm at 2,500 RPM. The intercooler is used to cool the hot air coming out of the compressor and reduce its volume. More of the denser air enters the cylinders and consequently improves the volumetric efficiency and increases power and torque. Motion is transmitted through a single block gear differential, an intermediate shaft supported by the front chassis to reduce vibration, and 2 drive shafts. The gear differential assembly is identical for the various versions except in terms of gear and axle ratios. The clutch has a diameter of 215 millimeters in the 2.0 and 228.6 in the other versions due to the fact that it has to transmit greater torques. The clutch works on a hydraulic system which gives a more comfortable drive. The gearbox is transversal with 5 synchronized gears plus reverse. Great technical precision has been employed in determining the gearbox ratios for the different engines. The gearbox differential spur gear set has different ratios for the different versions. Needle bearings on all the gears have made running even quieter in comparison with conventional gearboxes. The fork thrust center and the sleeve axis have been made to coincide to eliminate the possibility of the sleeves sticking. The shape of the hollows in the shift lever makes gear engagement even easier. Borg-Warner synchronizers have been fitted. Those for the 3rd, 4th and 5th speeds are mounted on the main shaft, whereas The first and second speed synchronizer is secured to the transmission shaft. The positioning of the synchronizers on both shafts takes up less space than when all the synchronizers are positioned on the main shaft. Gearbox external linkage consists of the following: a gear shift lever for selecting and engaging the gears, and an anchoring rod. The front of the anchoring rod is secured to the gearbox bracket with a flexible block, while the end of it is free to slide on another flexible block, which is bracketed to the tunnel. The special system of securing the gear lever means it can withstand oscillations from the gearbox engine assembly and consequently prevent gear slipping. The front part of the chassis has two main functions: to integrate the support structure, that is, it reinforces the body. It supports the engine gearbox assembly, the power steering, and the lower front suspension arms. These assemblies are pre-assembled on the chassis before being fitted to the vehicle, which makes assembling operations easier and more precise. The engine gearbox assembly is attached to the chassis with three supports: two hydraulic supports on the engine side and one rubber support on the gearbox side. The hydraulic supports have succeeded in achieving a satisfactory compromise between two contrasting requirements: the need to reduce engine shake and to limit engine vibration to the body. The engine gearbox is also connected to the body by a lengthwise adjustable tie rod. A McPherson front suspension with hydraulic shock absorber and a slightly out-of-line spring have been fitted to give a more comfortable ride. The front suspension also includes a stabilizer bar. The vertical shock absorber strut is positioned with its bottom attachment below the wheel axis and has been pushed forwards to prevent interference with the drive shaft joint. This arrangement means that the top suspension fittings can be positioned lower than in conventional suspensions, giving rise to the new bonnet line. This new, more aerodynamic line of the bonnet does much to improve the vehicle's CD. The rear suspension is simple, light and functional in terms of road holding and comfort. The rear suspension consists of independent semi-suspension, each one containing a McPherson strut and coil spring, which are mounted out of line, two control arms secured to a chassis fixed firmly to the body, and a longitudinal push rod. The two control arms are almost half the width of the vehicle and limit the track variations caused by suspension shaking. One arm can be regulated for each wheel when adjusting the rear wheel toe-in. The rear suspension also has a stabilizer bar which varies according to the model. The steering wheel can be tilted or telescoped. An intermediate shaft and two universal joints are used to connect the steering column to the steering box. The joints are aligned so as to spread out the steering column's sticking points and distribute the load more evenly on the steering wheel. The vehicle has standard power-assisted steering, which has the same ratios and features for all versions. The power-assisted steering system consists of a fluid reservoir located in the engine compartment, a vane-type pump driven by the engine with a relief valve and flow control valve, a hydraulic rack steering box, a set of connecting pipes. The power steering pump, operated by the engine via a belt, works at different pressures, from a minimum of 3.5 bars in a neutral position to approximately 85 bars when the steering wheel is on full lock. The braking system, designed in accordance with the vehicle's weight and the power used, has advanced efficiency and safety features. This braking system is of the vacuum-suspended power braking type, with discs on all 4 wheels and a load proportioning valve on the rear axle. There are 2 diagonally split braking circuits. If one of the circuits breaks down, the other continues to provide 50% braking efficiency on one front wheel and the opposite rear wheel. This arrangement gives the vehicle considerable stability in this sort of critical situation. The brake system uses floating calipers and self-ventilated front discs. The use of floating calipers and self-ventilated discs permits continuous heavy braking without causing the brake fluid to overheat. The rear calipers are fitted with self-adjustment devices for the hand brake. Depending on the engine version, the braking system varies in the size of its front discs, in the corresponding brake calipers, and in the setting of the load proportioning valve. The rear suspension arms are mechanically linked to the load proportioning valve, which regulates the braking force according to the vehicle's load. The braking system used on the 164 includes a highly sophisticated option, the ABS anti-lock or anti-blocking system. This device is inserted in the braking system to prevent the wheels from jamming when the brake pressure is too great for the wheel to rein hold. The ABS system thus guarantees vehicle stability, steerability, optimum braking distance. The device consists of 4 wheel angular speed sensors, electronic control unit which processes signals from the wheels, electro-hydraulic control unit which regulates the braking pressure, optical indicator on the cluster to indicate that the system is operating efficiently. To sum up, the 164 is an extremely original vehicle, has dynamic, highly modern lines, and strikes a perfect balance between elegance and comfort, between driving safety and brilliance of performance, in the true spirit of Alfa Romeo tradition. The 164, therefore, is aimed at customers who want a car that excels in every respect and that makes driving a real pleasure. Customers who want, in other words, an Alfa Romeo.